Hi, I am Madam Rosmaya. I am a physics teacher at SMJKUA Kajang, Selangor. And welcome to my YouTube channel. In this video, we are going to discuss example on projectile. Okay, let's say an object is thrown horizontally with initial velocity Vx from a height of 2 meter, and it land on the ground later at time t at the distance 2.8 meter. So we are going to find the time taken for the object to reach the ground here, and we are also going to determine the horizontal velocity for Vx, and also the velocity of the object when it reach the ground here. Okay, first question, to determine the time. So from the three linear equations, v equals to u plus at, v squared equals to u squared plus 2as, and s equals to ut plus half at squared. So which one is the suitable to be used to solve for time? So we choose the third one, s equals to ut plus half at squared. Why? Because we have a we choose a vertical component. Okay, so vertical component we have 2.0 meter. Okay, at the peak here, 2 meter, and then the u is the initial velocity, where the initial velocity for vertical component is 0 at the peak here, and then the a also we know which is negative, which is positive 9.81, because the motion is going down, same direction as the g value. And the only variable that which is unknown is t. So now we substitute all the values. S 2.0, u is 0, times t will be 0, then plus half, positive 9.81, and t squared. Okay, so we rearrange this equation to get t. So become square root of 2.0 times 2 divided by 9.81. So the answer is 0.639 seconds. So the time taken for the object to reach the ground here is 0.639 seconds. Okay, done for the question A. Next we do question B. Okay, to determine the horizontal velocity x. So from these three linear equations, so which one is the best to be used to determine the Vx? Okay, the most suitable is the third equation. Yeah. So why we choose this? Because u is the initial velocity, so we choose horizontal component. So we choose horizontal component. So for horizontal component, so the u here is equals to the Vx horizontal component, and the s here is 2.8, and half, a is 9.81. So time taken we have calculated in a question, so we can determine the Vx. So at any point along the projectile here, the horizontal component of velocity, which is Vx, is all the same. So now we substitute all the values. S 2.8, u is Vx, time taken 0.639 plus half, the acceleration, horizontal acceleration is 0, because this is horizontal component, so not 9.81. And lastly, t 0.639 squared. So the terms here is equals to 0. So the equation becomes Vx equals to 2.8 per 0.639. The answer is 4.38 meter per second. Okay, done for the B question. Vx equals to 4.38 meter per second. Next, we are going to find the velocity of the object when it reaches the ground. So again, from these three linear equation, we choose the most suitable to be used to determine the V at the ground. Okay. See. So at the ground here, the point at the ground, so the V at the ground is tangent to the curve, the projectile curve. This is the V direction. So to get this V, we have component X, Vx, and component Y, Vy. And we can solve V by using Pythagoras theorem. But we must know the Vy value. So the Vx value, no problem. We have calculated in B 4.38 meter per second. So remember that at all point along the projectile path here, the Vx component is the same. All has the Vx value equals to 4.38 meter per second. The only changes is in Vy. So at the when reach the ground here, the object has Vy. We are going to calculate now the Vy. Okay. So for Vy, from these three linear equation, which one is the best to find the Vy? So we choose the first equation, V equals to U plus AT. Okay, so we choose the vertical component because the V for vertical component is Vy, and then the U initial velocity for vertical component is 0 because at the peak here initial velocity is 0. And then A is 9.81 because vertical component, so we can choose 9.81. And the time taken calculated at A question. So now we substitute all the values. Vy equals to 0 plus 9.81 times 0.639. So the answer for Vy is 6.27 meter per second. Okay, so this is Vy. Okay, next to find V from the triangle here, we can use Pythagoras theorem. So the Pythagoras theorem, this is a right angle triangle. So the Pythagoras theorem said that V equals to square root of Vx squared plus Vy squared. So we substitute the 4.38 into the equation and 6.27 into the Vy in the equation here. So therefore the velocity of the object when reach the ground here is 7.65 meter per second. So this is the answer for C. Okay, next we are going to find the angle to represent the direction of the V. Okay, to find the angle here, named as theta, we can use trigonometric ratio. So we use tangent, theta equals to opposite per adjacent. 6.27 per 4.38 from the right angle triangle here. And the answer for theta is 55.1 degrees. So this represents the direction of the V when reach the ground here. Okay, so we've done the question. Okay, the end, and thank you for watching. Hope that you can understand the example given here.